All right, so we are the last section of the last topic in chapter 1 for today. We're going to see or discuss a little bit about the hierarchy that all the networks with which we configure, the different layers in a hierarchy that they fall into. Cisco has basically a hierarchy with which it places all the networks and all the networking devices in a particular network. So when you have a network and you see a network functioning and you see a series of networking devices that are functioning, you got to know that each and every one of those networking devices, they are performing roles or functions or tasks that will place them at a particular layer of the hierarchy in a network model. So let's look at the three layers of that hierarchy. Cisco has these three layers: the core layer, the distribution layer, and the access layer. And as the name implies, the core layer, this usually signifies the backbone of the network. That's where the major chunks of huge large of data. So each and every one of those devices, they function within either one of these three layers. The core layer, as you're seeing here, this forms the backbone of the network. The huge chunk of data, of traffic that you're going to have to send, these will go on within the core layer here. So whatever networking devices that you're configuring and you know that they are going to carry huge chunks of data traffic, that will function, those devices will function at the core layer of the network. So it's very important for you to know what networking devices you are putting in here. Okay. So basically that is it for the core layer of the network. So all the networking devices here that are programmed to function here, or any networking device, most of them are usually the high-end networking device that is programmed or configured to allow huge chunks or large chunks of data to be sent from one network to the other. That particular networking device will be functioning at the core layer. Now, as was mentioned before, it's very vital to know that these layers are not physical layers. They are more or less logical layers. So basically, don't look out for going, so that it will prevent you going into a network and then trying to look out, okay, where is the access layer, where is the control layer, the distribution layer, or the core layer. These things are basically logical. They're just trying to let you know that for a particular networking device, if this is what that networking device is doing, then it's definitely going to be. So we also have the distribution layer, which is also known as the routing layer. So basically, the devices that will be categorized as falling under this layer are devices that their own responsibility is just for them to switch or provide routing capabilities to a network, to be able to route data from one network to another network. So if you have networking devices that are performing the routing role, be they routers or be they layer 3 switches in some cases, then those devices will be functioning at the distribution layer. Whereas the access layer is just, as the name implies, to provide network access to users, just to connect users to a particular network, to help them or give them the ability to access network resources. So if, for instance, I'm a user that has a computer here and I'm connecting through the computer port, the internet port, I connect my computer to the switch or to a hub, then I am actually operating at the access layer. If I'm connecting my wireless phone through a Wi-Fi to the access point of a network or the Wi-Fi router of a network, then I'm actually also operating at the access layer. So these are the three basic layers that every single network device will fall under. So it's important to know that each device, a particular device, can function at 2 layers of the network. So you can have a switch. Depending on the type of switch, there are different sophistications of switches that will be performing the access layer role while also providing the distribution layer role. You can also have a router that is also functioning at the distribution layer and also functioning as the core layer. So the key to knowing these things is just to remember that these are just roles that networking devices are performing, and this will determine the kind of layer in which they fall under. Alright, now let's look at them one after the other a little bit more closely, starting with the core layer. Here says that the core layer is literally the core of the network because it is at the top of the hierarchy. Its responsibility is to ensure that large amounts of traffic are sent or transferred reliably and quickly. So this is the core determining factor for this layer to send large amounts of traffic reliably or unreliably. That's reliably using TCP or unreliably using UDP. But the key point is they need to be very fast. The only purpose of the network's core layer is to switch traffic as fast as possible. The traffic transported across the core layer is common to a majority of users. However, remember that user data is processed at the distribution layer. Then it is now forwarded to the core layer. So in this case, data is fed, unlike the OSI model where you have the application layer, the presentation and the session, and the data flows from the top layer to the bottom layer. With regards to the hierarchy, the information or the data or the information that is to be sent over the network, it flows from the bottom layer to the top layer. So data flows from the access layer, the user with his computer or with his cell phone or whatever networking device the user is using to access the network. He accesses the network, does one or two things to the network, prepares information that is supposed to be sent across the network. That information is now from the access layer, it is now sent to the distribution layer for the router to think of how best to route that particular data to the intending recipient. The router then, depending on the size of the data, will now know if to distribute it or to now send it, because if necessarily the recipient is on the same network or in a network that is connected to the router, then the router will have to take care or handle the distribution of that network information directly by itself. But if it's in a distant network where it doesn't have direct connectivity to that network, the router will now have to think of how to route that data through the core layer to the intending recipient. So that is how the data usually flows in the hierarchy of a network, from the bottom layer to the top layer. So that's to explain the comments that was made in this particular statement. Now, if there is a failure in the network, in the core, every single user can be affected. So usually the core layer, you can have things like the major ISPs, internet service providers, having their network functionalities at this layer. So you can imagine maybe one huge telecom network having a backbone core layer, and something happens and the core layer is faulty. Then that means every single subscriber making use of their telecom network for internet connectivity, they will be having issues with their connectivity to the network. So it's very vital that you do not allow faults to develop within the core layer. That's why here is saying that the fault tolerance at this layer is very key. It has large volumes of traffic, so speed and latency are very huge concerns. You must configure it in such a way that you have a high bandwidth, you need to have high processing networking devices that can process things at a very huge speed and then help to boost the speed of the network. So the core is likely to see large volumes of traffic, so speed and latency are concerns here. Given the function of the core, we can now consider some design specifics. Let's look at some do's and don'ts when you are configuring your network to function at the core layer and when you're configuring the network to function at the different other layers. Now, when you are designing a network and you know that that network is going to function at the core layer based on the responsibilities of each and every one of those networking devices, these are some things you should have in mind. Don't do anything that will slow down the traffic. So basically anything that has to do with things that could slow down traffic. So when you're designing a network or you're configuring networking devices that you know are going to function or they're going to operate at the core layer, you want to refrain from certain things that could tend to slow down that particular network device and prevent it from forwarding or processing forwarding data traffic at a very fast rate. Some of the things are things like access lists. These are things that are used to implement network security. So at this stage, this is not the stage where you want to look out for network security. No. Your major concern at this particular layer of the network is maximum speed, maximum data delivery, huge bandwidth, huge data access. Data connectivity. That is what you're looking out for at the core layer. So eliminate things like access list or routing, virtual LAN routing, packet filtering, and all those things. These are things that you do to secure a network, and it's definitely not at that particular layer. Refrain from implementing work group access there. So this is not the layer where you implement certain work groups, you create virtual LANs, no. And avoid expanding the core, like adding more routing, more routers, more high-end networking devices, because the more you do that, if you can remember what we discussed when we were looking at breaking up a collision domain, the more you're breaking up a collision domain or a broadcast domain, especially when you're using routers, you're breaking a broadcast domain, you're also increasing the number of networks. So increasing the number of networks will make that networking device spend a little bit more time in trying to route the huge chunk of data that you're trying to send at that core layer to the intending recipient. So you want to refrain from making the network a little bit too big at the core layer, because you can imagine, think of something like a pipe, a two-way pipe that you have one end and another end. It's just simple. You just know that it's just only one direction and only one movement is allowed. But when you now have a pipe that has different branches, up to 3, 4, 5 branches, definitely the speed at which what you're sending in a single pipe is not going to be the same as the speed of what you're sending in a pipe that has multiple branches. That is the best illustration to help you appreciate why it's not best to increase the number of networks at the core layer. Now, these are some of the things you can do to make your core layer network design much more better. Design it with such a way as to have high reliability. So use technologies that will provide a whole lot of speed and redundancy. Technologies like FDDI, fast Ethernet, or in some cases Giga Internet, or even ATM. So we'll come to see each of these concepts as we go down in our book. Then also design it with speed in mind. They should have very little latency. Use routing protocols if you must use routing protocols that will have a lower convergence times. That means a kind of routing protocol that if there for any reason any fault develops, the fault will be able to correct itself in the least possible amount of time, in a way that users will not even notice that anything went wrong. We're going to look at that a lot more as we go down in the book. So fast and redundant data link connectivity is no help if your routing tables are short. Alright, so that's it for the core layer. Now let's look at the distribution layer. The distribution layer here is sometimes referred to as the workgroup layer, because it is at this layer that all the configuration that you need to do to protect your network, this is where it is done. It's also the intermediate layer that communicates between the access layer, which is the first layer, and the core layer, which is the top layer. The primary function of this layer is just to provide routing, filtering, that's wireless area network access, and to determine how packets are accessed at the core if needed. Meaning that it's this guy now, the routing layer, the networking devices at this routing layer. So maybe when you're designing a network and you know that the networking devices, based on the activities they are going to do, such as the routers and the rest, that the activities they are going to do will fall under this distribution layer, then these are the things that you are going to look out for. You're going to make sure that those routers can provide adequate routing, those routers can filter packets, such as maybe like check some internet sites that you don't want to be visited, block some internet sites, restrict all those user restrictions and security checks, policies, network policies that are implemented at any networking device that is going to function at this layer. So the distribution layer, sometimes it determines the fastest way in which the network service requests are handled. Okay, so if a file request is forwarded to a server, the networking device at this layer will know if it's to do that itself or forward it to the core layer. After the distribution layer determines the best path, it forwards the request to the core layer if necessary. The core layer can then quickly transport the request to the correct service. So what that means is, since the distribution layer is the intermediate layer between the access layer and the core layer, And we mentioned that the information or networking information flows from the bottom layer to the core layer. It's at the distribution layer that the networking device functioning here will now know whether the information that you are sending, it should just distribute it to, okay, that is intended for a recipient on a network that is on one of its interfaces, and it can as well just switch over the information to the recipient who is on the other side of the network. In that case, it will not have to pass the information to the core layer. It will handle that network requests at that distribution layer, and the request won't climb up to the network layer. But if it now probably notices that the intending recipient is somewhere outside of the network in which it hosts, it will now send the network request to the core layer, for the core layer now to forward it into the intending recipient. So sometimes the data, it doesn't mean that every single time or every single instance the network request will move from the access layer to the distribution layer and to the core layer. Sometimes it stops at the distribution layer, and the devices at that layer handles the request and settles it once and for all. But in cases where it cannot settle it once and for all and doesn't know how best to forward it, that's when it will now send it to the core layer. So these are some of the things you need to do when you're designing a network and you want to configure your network devices to operate or to provide distribution layer services. Okay. You're going to have to implement things like routing, using routing protocols to be able to determine where or how to send network requests. You're going to implement things like access list, packet filtering, and queuing. This will help for you to secure your network, to monitor and checkmate what users of your network can access and what they are banned from accessing. You can use this also to implement network policies. At so time a particular site should be shut down, at so time a particular site should be up, and providing firewalls for security. You can also configure routing protocols or static protocols at this level. You can provide virtual LANs or work access group or work group support functionalities. You can also create broadcast domain or multicast domain. So things to avoid at the distribution layer are limited to things that are performed by the other layers. So you don't go and configure core layer functionalities, you bring it to the distribution layer. No, neither do you go and configure access layer functionalities to the distribution layer. No, each of those layers will be configured to handle the things that they are suited for. Now that brings us to the access layer, which is basically the layer where every user of the network is connected or is given access to the network resources. So the network resources, usually they will need to be available locally. So in the instance where maybe you want a particular situation whereby, take for instance in like a cyber cafe, whereby if you come and you want to make use of the network, you must key in the username and the password. These are some of the functionalities or the configurations you can do at the access layer using the access layer devices. So things you can configure at the access layer, you can also do access control or policies. You can create so many collision domains. You can create workgroup connectivity, creating virtual LANs, creating multicast domain, and the rest of them. So we'll look at much of this concepts or terminologies as we go further and further. So technologies such as the DDR, Ethernet switching are frequently seen in the access layer. Static routing are also seen at this layer to make it easier for them to send information from the user to receivers, especially in the cases that are known. So they are also there, and so on and so forth. So that's it for the three layers of a network, the three layers in which all the networking devices that we have on the network would either fall into. Remember, we mentioned that some of those networking devices can perform more than the roles in more than one of the layers. One device can function at the access layer and also function at the distribution layer, and it can also function at the distribution layer. That's another, a networking device can also function at the distribution layer and also perform the role at the core layer. So this is more or less to summarize everything that we've learned so far in this chapter 1. We've looked at the OSI model. Starting from there, okay, we're able to look at the collisions. When we discuss collision domains and broadcast domains, we're able to see how they are created and how they are segmented, what devices are used to create them, what devices are used to segment them. We're also able to see the OSI model. We're able to see each of the 7 layers of the OSI model, the different things that they have done at those layers, and how those activities help to boost and speed up network communication. we're able to see the different other things, the packets, the reliable data transfer, and the rest of them. And then lastly, we're able to look at the 3-layer hierarchy model. Now, these are some exam essentials, things you'll have to have in mind when you are preparing for your exams. You need to try and remember some of the things that causes LAN traffic congestion. You can remember them when we're discussing about broadcast storms, multicast, and collision domains, both broadcast and collision. So go back and look at them and take time and read the chapter 1 everything very well so as to be able to remember them very well. You need to remember the difference between a collision domain and a broadcast domain. How are they created? What is used to create what? And how are they segmented? How do you break them? How do you the effect each and every one, which devices are used to break up a collision domain and which devices are used to break up a broadcast domain. You also need to understand the difference between a hub, a bridge, a switch, and a router. How do these things affect the network domain, both broadcast and collision? Find out, remember. And you need to remember connection-oriented and connectionless network services, how these are done. So remember TCP and UDP, read all of them, how the network sets up itself for connection-oriented and connectionless data delivery. Then look at your OSI layers again, each of the layers, the protocols that function on each of the layers, the activities that go on each of the layers, the encapsulation process that go on each of the layers. Remember them very well. Remember the types of Ethernet cabling that we discussed, the straight-through cable, which are basically used to join different networking devices, such as a computer to a router's interface, a PC's or a router's interface to a hub, as in it's used basically to connect, a PC to a hub, a PC to a switch to a router, a hub to a switch, and things like that. Whereas crossover cable are basically used to connect similar devices. You can use it to connect a hub to a hub to a switch to a switch, a PC to a PC, or a router to a router. Whereas a rollover cable is now used to connect a PC to the console port of either a router or a switch as an administrator for you to be able to do some programming or configurations on your networking devices. So you need to remember how to connect your console cable to a PC or a router, as we mentioned, or as was discussed in a particular section of that book. Make sure you look at it and remember it. And then lastly, the 3-layer hierarchy model that we've just considered today. So look up all this. I'm going to send you a series of questions that will summarize everything that we've learned throughout this chapter 1. You're going to answer them and then send them over. I'll mark them and grade them and send them back to you to let you know your performance. That will now determine if you have all the concepts that we've discussed in the chapter 1 closely registered in your memory, and we are good to go on the chapter 2. So see you soon, and we're making progress.